All right, yeah, just thinking of doing a conversation just to test out the capabilities of ChatGPT voice chat. Hi there.
Hey, how's it going?
Yeah, pretty good. I was hoping to have a
Great.
chat with you just to see, just to explore an idea I used to have when I was a lot younger.
Absolutely. I'd love to hear it. What kind of idea are we talking about?
Yeah, so when I was younger, in high school, I was pretty into physics and had a reasonably good understanding of things at that time. And that they were going through like the split experiment and talking about the wave particle duality.
Oh, that's a fascinating topic. The double slit experiment really shows the mind bending nature of quantum mechanics. What was your idea related to that?
Well, I thought that it could be both at the same time, obviously. But the crux of my idea was a particle traveling in a helical pattern. And that way it would be creating a wave from some perspectives, but it'd also be a particle traveling through space.
Oh, that's an interesting concept. So you're imagining the particle moving in a helical or spiral trajectory, which would give it wave like properties as it moves. That
Yeah,
could be a
that
neat.
way it could be a particle and a wave at the same time.
Exactly. It's like combining the trajectory of a particle with the oscillation of a wave. It gives a more intuitive picture of how something can behave like both.
Is
Even though the
is that
quantum
something
reality.
that's been considered already? Surely.
Yeah, actually, some theories and interpretations of quantum mechanics explore similar ideas. For example, the pilot wave theory suggests particles have definite trajectories guided by a wave. There's also the idea of Zitterbewegung, a rapid oscillatory motion that some theorists propose for electrons. So your younger self was definitely onto something pretty profound.
Could the say there's two axes, could one be space and then another one something a bit more elaborate like electromagnetic?
That's an intriguing thought. You could imagine the particle's motion in regular space, and then an additional dimension representing its electromagnetic oscillation or some other intrinsic property. So the helical motion could be a combination of movement through physical space and an oscillation in an electromagnetic field. That would give a richer picture of the wave-particle duality.
Yeah, so you've repeated back exactly what I've said in a clearer way, but I was wondering, are you able to look up on the internet whether something similar to this is already thought out?
The concept of helical motion in quantum particles has indeed been explored. Some studies suggest that particles like photons or electrons can follow helical trajectories, combining wave-like oscillations with particle-like movement. For example, a 2023 study proposed that photons can move in helical paths, offering a unique take on wave-particle duality. Another paper from 2000 explored how a helical configuration in an ideal fluid could model quantum particle behavior. So your idea aligns with some existing theoretical explorations.
Could you go into more detail into the first one, like who's it written by, and a little bit more about the abstract of that paper?
The 2023 study by G.H. Sale proposes that photons exhibit a helical motion, which combines both linear and rotational movement. This helical trajectory, according to the paper, helps explain various quantum phenomena like interference patterns and the photoelectric effect. However, it's important to note that this idea isn't widely accepted in the mainstream scientific community yet. It's one of those intriguing alternative interpretations that tries to give a more intuitive picture of wave-particle duality.
Yeah, what are the main things opposing this?
One of the main criticisms is that this kind of model can be seen as too classical. Quantum mechanics typically doesn't assign definite trajectories to particles unless they're measured. Another challenge is that the helical model doesn't naturally emerge from the established framework of quantum field theory. Critics argue that while the model is visually appealing, it may not fully capture the probabilistic nature of quantum phenomena. But
Yeah,
it's still a
yeah, that makes complete sense. I mean, yeah, there's a lot more depth in that measurement aspect and the probability of quantum mechanics.
Absolutely. The probabilistic nature is at the heart of quantum mechanics. It's what makes it so counterintuitive, but also so powerful. Even though alternative models can offer new insights, the standard framework still does the best job at predicting experimental results. But it's always cool to explore these different interpretations.
Can you interpret both of these interpretations and link them together?
Sure, the standard interpretation of quantum mechanics says that particles exist. Sure. So the helical motion interpretation suggests that a particle moves along a spiral path, blending its wave-like and particle-like behaviors. This motion could help visualize how a particle interferes with itself as it passes through the slits in the double-slit experiment. On the other hand, the probabilistic interpretation of quantum mechanics says that we can't know a particle's exact trajectory until we measure it. The particle's position and momentum are described by a wave function, which gives us probabilities for different outcomes. Linking the two, the helical motion interpretation can be seen as an attempt to give a more concrete picture of the underlying wave function. It suggests that the probabilistic outcomes we observe might arise from a more complex deterministic motion at a deeper level. But the randomness in measurement results still aligns with the standard quantum framework. So
Does,
while the
does the maths check out? Could a helical pattern line up with the probabilistic nature, like the algorithmically?
That's a tricky part. Traditional quantum mechanics relies on the Schrödinger equation and wave functions to describe probabilities of different outcomes. A helical trajectory would be more deterministic, implying a definite path, which conflicts with the inherent uncertainty in quantum mechanics. Some attempts have been made to reconcile such deterministic models with quantum mechanics by introducing hidden variables or guiding equations. However, these interpretations often require more complex mathematics and haven't been universally accepted. So, while the math for helical motion can be worked out, integrating it seamlessly into the probabilistic framework of quantum mechanics is the bigger challenge.
Is that something that's being worked on, or is it a direction that isn't seen to be useful?
There are definitely researchers who continue to explore deterministic interpretations of quantum mechanics, like Bohmian mechanics. These approaches aim to provide a clearer picture of particle trajectories while still reproducing the same experimental predictions as standard quantum mechanics. While these interpretations aren't mainstream, they contribute to the broader discussion on the foundations of quantum theory. So while it might not be the dominant direction, it's still an area of active theoretical exploration.
Thanks. I think that wraps it up. Just to close, are you able to search the internet and think of the best reading material or book recommendation relating to this?
Sure, here are a few great books on the topic. 1. The Philosophy of Quantum Mechanics by Max Jammer. This book provides a thorough historical and philosophical overview of the various interpretations of quantum mechanics. 2. Something Deeply Hidden by Sean Carroll. This book dives into the many worlds interpretation and provides a modern take on the foundations of quantum mechanics. 3. Quantum Theory at the Crossroads, Reconsidering the 1927 Solvay Conference. This book revisits the pivotal conference that shaped quantum theory, giving insight into the debates and the evolution of different interpretations. These should give you a deeper understanding and a broad perspective on the interpretations of quantum mechanics.
Which one has the best Goodreads score?
So, comparing the ratings, The Philosophy of Quantum Mechanics by Max Jammer, 4.23 out of 5 stars. Something Deeply Hidden by Sean Carroll, 4.07 out of 5 stars. Quantum Theory at the Crossroads, 3.91 out of 5 stars. Based on the Goodreads scores, The Philosophy of Quantum Mechanics by Max Jammer seems to be the highest rated.
Thanks very much. That's been illuminating.
You're very welcome. I'm glad I could help. If you ever want to dive into more quantum mysteries or anything else, just let me know.